Hey everyone, welcome back to another CS 128 Honors Lecture. Today we're going to cover enums and how to use the match keyword with enums in Rust. So first we're going to introduce you guys to what enums are, the general idea, then go more in depth on the two most common enums you'll see in Rust, the result and the option type, which Eustace should have introduced to you last lecture. Then we'll go over control flow with enums using the match keyword and and what that looks like. And then we'll show you guys how to make your own custom enum types in Rust. Finally, at the end, we're going to just go over homework 1 and MP0 briefly. I'll give you guys a couple hints to help you guys get started. So first, a couple course announcements. Homework 1 was released last Tuesday. It'll be due on the 8th at midnight. Homework 2 releases today. It'll be due on the 10th at midnight. MP0 is also releasing today, but it'll be due February 11th at midnight. And as always, we're happy to give you guys extensions when you need them, but we do require that you have made some progress on the homework or MP, unless you have a valid excuse. So if you think that you need an extension, please reach out to Eustace or I on Discord, and we'll be happy to help you out. Also, homeworks will have a feedback survey allowing you to say whatever you need to, ask any questions you need to, reach out to us using that feature or on Discord. And one final announcement, we did make a little bit of a mistake on homework 1. We asked you guys to categorize some items, Spider-Man being one of them, and unfortunately we used the wrong version of Spider-Man. We forgot the hyphen. So when you're completing homework 1, you're unfortunately going to have to use the Spider-Man spelled without a hyphen. Okay, on to the lecture. So what are enums? Enums are custom types with a restricted set of values. This can be like the colors of the rainbow, an undergraduate student level, so freshman, sophomore, junior, senior, or the day of the week, Monday, Tuesday, Wednesday, so on and so forth. They make your life as a programmer much, much easier. Rather than trying to represent some type with a string or an integer, you can assign meaning to a type by giving it a name. So in your code, you can literally call enum Monday, and you'll have a meaningful type that is super easy to read, and you're not having to deal with strings or integers and figuring out what each type means. We'll sort of show you more about what this means as we dive deeper into enums. So Eustace showed you guys what the option enum type was in the last lecture. So as the name indicates, the option type represents an optional value. Every option either takes the enum variant of some or the variant of none. And when it takes the value of some, the option contains a value. You can use that value throughout your code after you've extracted it from the sum. And we'll show you how to do that in a bit. If it is none, it does not contain a value. You cannot sort of extract any value, and if you do, or you try to at least, your code will panic. And more on that in a bit. So this is sort of analogous to using the null or null pointer in Java or C++. When you do not have a value to return, you can return null. But the problem is in Java and C++, you can get a null pointer exception when you try to dereference it. In the case of Rust, you have efficient ways of checking whether or not you're some or none, and you will not get a null pointer exception because you can't dereference it. There are some sort of drawbacks, and we'll get into that, but makes your life a lot easier. So you can use option for functions that return values that are not defined sort of over the entire input range. So what does that mean? Let's say you have a vector or an array. They are of a certain size at any given moment, right? If we have a vector of 10 elements and we try to access the 11th element, there is no value there. So when you try to get the 11th value, we can return a none. If we try to get a 0th value, the first value, we can return a sum, and the value contained in that sum is the element we want. So like I said, this has similar usage to returning null or null pointer in Java or C++, but you cannot get a null pointer exception. But in Rust, there is this thing called panicking, and I'll show you what that means when we get into some examples. Okay, let's show you how to use option. So I have a vector of numbers here. You can use the vec macro that I used to show you guys last lecture to create a vector of 6 numbers, 128, 199. We can get values from our vector using this get function and providing the index. But you can see get returns an option. So like I said before, if you try to get a number out of the range of our vector, out of the, past the last element, you'll return none. And so let's try that here in this loop, right? We have 6 elements in our array, but we're trying to access the 7th element in this loop. So we'll get the index for each index in our range, 0 to 6, 7 being not inclusive, and print it out. The new piece of syntax to note is this colon question mark inside your print formatting. This is how you print out non-primitive types, so like option, like printing out a vector. This is what tells Rust to know that there's some sort of special formatting going on. Okay, let's go ahead and run this. So you can see that for the first 6 values, we're printing out sum. It's sum with a 1, sum with a 2, 8, 1, 9, 9, but at the end, when we're trying to access index 6, 0 indexing, we get a none. That's because our vector is 6 elements, and we're trying to access something out of bounds. So you can use the option enum to your advantage here. Okay, let's figure out how you can use the option enum yourself. So I have this function here, get Discord staff role. So as you know, there's 8 of us on the core staff here, and we want to sort of get what role each person is. So I've sort of used this match keyword here on these ampersand strings. We can give some options separated by a vertical bar to indicate that it could be this or that. So Eustace or Neil is an instructor, while Virjona is an admin, so on and so forth. But if it's not one of these options that we specified above, we don't want to return a Discord role because we're only looking for staff. At the moment, I have it set to just returning student, but is there a better way we can do that? Well, the option enum allows us to. So instead of returning just a string, we can return an optional string. And so in order to do that, we just have to wrap the return values in a sum. So we can do that for the 3 cases where we do want to return something. And in the case that we do not, can just return none. Okay, let's move on. Eustace introduced you guys to the result type enum in the last lecture. So the result enum is used for returning and propagating errors. Rather than sort of exiting your program with an exception, Rust allows you to return this type that either contains a value of success, so OK, or some type of error. And each of these enum variants contains a specific value that you can extract from the enum variant and use throughout your programs. So when you receive an OK, you can continue with your program using that success value, let's say like an integer, a file, whatever it may be. If you receive an error variant, you can extract the error type and do something with it to control the flow of your program. You'll see results a lot in the standard input-output crate in Rust. So you're trying to open a file and the file doesn't exist, you can get an error variant and do something with that in your program. So when there is no meaningful value to be returned in the either success or the error type, you can use the unit type in that place. You can simply place the unit type as the value attached to the OK or error variant, and nothing will happen. Only do this when there is no meaningful value to be returned as either T in your OK type or E in your error type. Okay, let's move on. So there is a different way to sort of handle these option and result types. You can use the match operator that you learned about in the last lecture. So just going to reiterate this. You can use match to compare some value to a series of patterns, and then execute some code depending on which of those patterns you match. And those match patterns must be exhaustive. You must match every single type of pattern that you can receive. Luckily, in the case of option and result, there's only two real patterns that you'll see. Some with a value inside of it, or none with no value for option, and OK or error, each with a value inside. So right here, you can see that in our match statement, we have this sort of pattern sum, and inside we have a value. Val takes on the type t. So t is any type that that your option will return. In the case of our vector example, t took on the type of an 8-bit integer. Val will be whatever type is contained inside your option. So here, if we find a sum with a value inside of it pattern, we'll just print out the value inside. If we see a none pattern, we'll just print out nothing here. Matching with result is also very similar. If we see an OK with some value inside of it, we'll just print out succeeded and then print out the value as well. Whenever we see this error with a sort of E contained inside of it, we'll print out something went wrong followed by an E. So the big thing to know or to notice here is that when you're using match, you do not need to call unwrap to get the value. You can write just the enum variant and then some variable that you want to represent the value with, and you can use the variable in your lines of code. This variable will sort of be dropped. It will go out of scope after you leave this match statement, but it is handy to use inside your match statement. Okay, let's get into some examples of using match with your option and result type enums. So back to our sort of vector out of bounds example, we can match our option type that's sort of retrieved from our vector with the get method. So we can say match our retrieval, and we have two different patterns. Some with some number contained inside of it. We'll do something here. Let's say print it out. And print out our number with our format strings. And if we have a none type enum, well, let's just say we want to do nothing. We can do nothing by just signifying this unit type here. So Rust will see this, evaluate this, and do nothing. So I'll comment this out and run it again. So there we go. Yeah, 128, 199, and we do nothing when we try to access the index out of our range. Okay, let's see what we can do with the result type. Back again in our file printing example. So let's say we want to handle the case where we try to open a file that doesn't exist, right? Right now, we're just panicking and stopping the program because we expect the file to exist. But let's say we want to create a new file if the file does not exist at the moment. So we can use a match statement in our file variable assignment. So I'm going to match file open and then file name. And then this clone variable. This sort of comes into play when we cover ownership and borrowing. For now, clone will just copy the contents of the string file name. Okay, and so our error or our result variant can take on two enum variants, OK and error. OK contains the file struct inside of it. So when we see a file, we want to open it. We just extract the value from our OK variant and assign it to the variable file. If we see an error variant, well, we want to create the file. So we can do this in a sort of little code block right here. All right, we can say file create, and then unwrap it. So we're using unwrap here because we know that the file does not exist. So create will return an error if the file does exist. But we know the file does not exist because, well, we're in our error variant from the open call. And so we can create the file because we know it does not exist, and we can use unwrap because we are 100% sure that we will get an OK value here. Okay, so copy that out. And remember, we have to put a semicolon after our match statement because we're using it in some variable assignment. So I still expect this program to panic. Let's take a look why. So it's panicking on an error value on line 23, so right here. Well, as you can see, we're using another call to unwrap here. We don't actually know if line is an OK or an error. We're just calling unwrap. So you have to be very careful here. You have to be 100% sure that line is an OK. It has some success value corresponding to it. So we can use another match statement here. So match our result OK, and as you can see from my Rust analyzer extension, the OK type will contain a string. So string is line string, and we can go ahead and just print this out. Copy this over. And in the case where we have an error variant, oh, let's do nothing. Again, we can use the unit type to signify that we want to do nothing. There we go. So we created a file, source main.txt. You can see that here in my file browser. Whoops. We have a new file, main.txt, but it does not contain anything inside of it. And so there is nothing to print. Okay, let's move on. So we've talked about using option and result, some predefined enums in your code. Let's move on to creating your own enums to help you out in your code. So as you probably expected, there's an enum keyword. You declare enum and then the name of your enum type, so day of the week, and then you list out all of the enum variants. You enumerate them. So for the days of the week, we got the 7 days of the week. The standard syntax is to capitalize snake case, capitalize camel case this for the type and for all of the variants. And we can call or use our variant using this double colon operator. So day of week, double colon Thursday. And today will take on the type day of week. So there are some more enum variations. We can assign more value to our enums using tuple enums. Rust allows you to bundle any additional information you want to your enum states by creating named tuples. So what do we mean by this? Let's say we have a point. We have 3, 4, as many different types of points you want. Let's say we're creating a game engine and we want to do some vector math. We can have a 2D point represented by just 2 floating point values, or 3 type or a 4D type. But in here, you can see that we have tuples that are assigned to our enum states. So 2D is assigned to this tuple of 2 F64s. 3D has 3 F64s, and 4D has 4. So when we're declaring our enums using this double bracket operator, we have to pass in these values, sort of like function parameters. When we're creating a 2D enum variant, we pass in these 2 F64s, and we can use these in our code. So there is another variant called struct enums. We can use sort of struct declarations to assign a little bit more meaning than tuples. Structs are very similar to tuples. They they're pieces of information that are different types. But unlike tuples, you name the pieces of data, so you don't rely on the order that they appear in your declaration. So as a result, structs are more flexible than tuples because you can reorder the manner in which you declare parameters when creating struct enums. So we'll talk more on actual structs later in the course, but we'll review what struct enums look like right now. So let's say we're, again, creating our game engine and we want to handle some events with our mouse. So we have two sort of variations of this. We have a drag event and a click event. So with click, we have two sort of named parameters, the x coordinate of our click and the y coordinate of our click. And with our drag, we have somewhat more complicated type declarations. So in our struct, we have a from variable and a to variable, and each of these is a tuple of two values. So from is a tuple of two integers, and to is also a tuple of two integers. So notice the difference. In struct enums, we're using this bracket declaration to declare our variables and the types that they take on. With enums, we simply use parentheses and the type name. We have to provide variable names here with enums, with struct enums. And the same applies when we're creating them. So again, we use the double bracket operator, but we declare our struct enum using brackets, and then we must declare the variable name. So what I want you to notice here, though, is that the order in which we declare variables is different from the order in which they're declared in the enum declaration. That is the flexibility of struct enums. It does not matter the order in which you declare it. All that matters is the variable name that you use when defining your enum variant. And again, sort of you have this variable assignment, so x, and then a colon, and then the value you want it to take on. And so you can mix and match normal enum states, tuple enum states, and struct enums, as in the case of this web event. We have 5 different variations. We have 2 normal enum states. We have a single tuple enum state with a tuple of a single value, and then we have the struct enum. And so we can, again, declare these as you've seen before by just passing in the values if it's a tuple enum, or by declaring the variable name followed by the value if it is a struct enum variant. And as in the normal enum variant, you just declare the name of the enum variant you want. So let's get into an example of defining our own custom enum. So if you're following along, you can follow us in the order.rs file. So one thing I want to point out right away is we have this derive sort of funky syntax here. What this allows you to do is print out your enum variants using println statements. So you'll see that in this example. So we have our order status enum processing our order, packed it, shipped it, and delivered. And we have this function here that takes in our order status enum type. So like you can see, we have our match upon our order status, and our match is comprehensive. It covers all patterns that order status can take on, all 4 variants. And we're going to return a tuple of values that gives us an estimation of when our package is going to arrive. Another thing I want you to see is we're not actually calling the return keyword here. We're using a sort of implicit return with no semicolon at the end and no return keyword. And this does return our tuple of values. Let's see if we can use what we know about struct enums and tuple enums to attach some more state to our enum variant types. So with our delivered enum variant, maybe you want to attach a string to it to indicate sort of where the package was delivered. Maybe it's on the porch, maybe it's with the apartment manager. Wherever it may be, we can let the receiver know using this string. And with shipping, there's a lot of information we can attach to this. Let's say that there is a tracking ID that the receiver can use to find where their package is in the mail pipeline. So we can say that that is a use size, unsigned number, and then maybe we can also attach the time that the order was shipped at. A date time that the user can sort of use to estimate when they'll receive their order. Okay. And we can make a function to sort of print out the status of our order along the way. So print status, and a function will take in an order status enum variant. It'll return nothing because we're just going to print it out. And so we're going to copy this match statement over and modify it. Okay, so we're matching our status, but we need to match all the patterns correctly. So we're no longer matching delivered correctly because we're expecting a string to be here. So when we see a delivered enum variant, we'll have a message string here. We can unwrap the string value and assign it to the variable message and print this out. So order delivered at, and then format print the message. And then in the case of shipped, well, we have to extract these tracking ID and ship time arguments from it. So we have our tracking ID and we have our ship time. So notice that I'm using the exact same variable names as in my declaration. So Rust will bind this specific variable here to the usize and this variable here, ship time, to the date time because those names match. And so in this case, we print out the fact that order was shipped at, and we'll debug print the date time. Remember, you can debug print using the colon question mark operator on custom types with tracking ID. And tracking ID is a usize. It's a primitive type, so we do not need the debug printing. So we'll pass in the ship time to print first, and the tracking ID to print next. Okay. And in the case of processing and packed, we'll just print that out. The order is processing, or the order was packed. And copy that over. Okay. And so this match statement is no longer valid because, remember, we're matching patterns. And this delivered enum variant no longer matches the pattern that we've declared up top here. Delivered is no longer trying to find a string, and shipped is no longer trying to find the tracking ID and the ship time. These patterns are no longer valid, and that is why the compiler is complaining. I'm going to comment out that function for now. And here in getStatus, I'm just going to return some arbitrary status. Maybe my order was shipped with the tracking ID 123, and I'm shipping it at this instant right now. So I'm going to get the current time in the UTC time zone. Okay. And so I have my status, retrieving it from this function. Notice no return and no semicolon, this implicit return in Rust. You should get used to that syntax because you'll see it all over the place. And we're going to sort of debug format our status enum variant. So you can also use the debug formatting within the format macro, similar to the way you use it in the println macro. So we're going to call our print status function that we just made on the status enum, and maybe we'll print out the status string just to show you what it looks like when you debug print something. Okay. And let's compile and run our code. So here you can see the order was shipped at, and then we're printing out the UTC time zone, this current time, with tracking ID 123. And this is what it looks like when you're sort of debug printing this enum variant. So you have the shipped enum variant, and it's a struct enum with tracking ID 123 and a ship time of February 4th at 1:53. Okay. Let's move on. So we're going to sort of ask you to start testing your own code within your homeworks and within your MPs. We're going to provide you with a little bit of tests, with a little bit of some framework to help you sort of get started. But we're no longer going to be providing you with tests, so you're going to have to test your own code. You're going to have to write your own tests. So let's just sort of briefly cover what that looks like. So you can create a module for your tests within each file with the mod keyword. This is a sort of subsection of the file that will run your tests. You mark this module with the CFG test procedural macro. So this is different than the normal macros you're used to seeing, println, format, vec. This is a sort of annotation for modules and functions. And so you mark your mod with the CFG test to let Rust know that this is where your tests are going to be. And then within that module, you're going to write functions to test your code. So we'll walk you through this in a little bit, just to show you what that looks like. And you're going to mark each test with the hashtag test procedural macro. So this tells Rust that this function is a test, and so use it, run it when you're running my tests. So you can use assertion function-like macros to check for expected behavior. So there's the assert macro that checks if something is true. You have a statement here that must be a Boolean, and assert will make sure that this statement is true. If the statement is false, Rust will panic. So it won't stop your tests, but if you use assert in normal, in your main function, Rust will panic and exit the program if your assertion fails. But in your tests, assert is sort of like a test case. Then you have assert equals, which takes in two values. These two values must be the same type, and this assert equals macro will test if the two values are equal. And then opposite, assert not equals, Rust will check if these two values are not equal. So in this case, assert not equals, if the two values are not equal, the test will pass. If they are equal, this assertion will fail. Rust will panic. If it's in a test case, it will not panic. It will just show you a false or a bad test. So like I said, assertions will panic when they fail, and panics in test indicate that the test failed. Okay, let's get into some examples of writing your own tests. So as you can see here, I have my module to contain my tests, so mod tests, and then I'm marking it with the CFG procedural macro to let Rust know that I have tests in this module. So I'm going to start off by declaring that I have a test with the test procedural macro and function. Let's test adding. This is a sort of pointless test to check Rust adding, but you can sort of call your functions in here and test out your code however you like. So let's make a function here that add, and we'll take in a integer and another integer and return the sum of those two. So x plus y. Again, notice no return, no semicolon. Okay. So I'm going to import all of these functions by saying use super all. This is very important. This will grab all of the functions from outside of the module and use them in here. Okay, and so with my test adding, I'm going to assert that, let's see, adding two numbers, so add 1 plus 2 equals 3. And so I can run my test using just cargo test. So Rust will grab all of my tests, compile that, and run these unit tests. And so it's grabbing all of the tests from all of my files. Here you can see inside the unit tests, running one test, and that test passed. Okay, so let's try and deliberately fail a test now. So we know that 1 plus 2 equals 3. Let's try and say that they're not equal to 3. So assert not equal, add 1 and 2, and let's say that they're not equal to 3. All right, so if we run cargo test again, cargo will pick up all of our tests across all files and run them. Okay, so it's compiling these tests in order.rs, and here we go. Test failed, test adding, so you get some debug information here. So panicked at assertion failed, the left does not equal the right, but the left does equal the right, so our assertion does not pass. And just to show you, we can also use the assert macro. So assert that add 1 and 2 equals 3. And we'll comment this test out because we know it fails. Okay, so we can run this again with cargo test. And once again, cargo will pick up all of our test functions and run them. Here we go. All right, great. All tests passed. Okay, let's sort of move on to the MP and homework walkthrough. Right. So if you pull up PrairieLearn, let's see, we have homework 2 has been released tonight. It has 2 problems, one covering enums and result types, and a feedback survey. So please fill out the feedback survey if you have any questions, comments, or concerns. Let's get right into homework 1. So we have a couple of functions here, and we've given you 2 different enum types. And so we're giving you this derive macro to allow you to print out these enum types here. So what you're going to do is use a match statement to sort of extract a result from this optional color. So if you see a specific color as a string, you're going to return that as an enum color with a OK option because you found that color. And in the case where you do not find the color for some reason, you're going to return an error variant with one of these color error enum variations. So color error is your E type that is wrapped up in your error enum variant. And then you have this sort of Fibonacci function. So I would strongly recommend that you complete this Fibonacci iteratively. So do not use recursion. Keep your life easy. So compute some Fibonacci sequences and return a tuple in an option enum. So I'll let you figure that out. And we can move on to MP1. So in MP1, you're going to be designing a basic calculator. So you're going to take in a string that has an expression with either 1 or 2 numbers. So if it's 1 number, you simply return that number. Otherwise, you sort of perform the calculation contained in that string. And so there's 5 operations: addition, subtraction, division, multiplication, and modulo. So be very careful. In multiplication, we're asking you to consider both the sort of asterisk and the X symbol. So I imagine that you'll need to use a sort of match statement to handle matching these characters, and use the underscore operator to handle the case where you do not see one of these symbols. So you'll be completing that within this from car function. I'd imagine that you use the none option variant if you do not find a character you're looking for, if you do not find a symbol. Okay, and then we have 3 more functions for you to complete. So we have this parse equation function. So you're going to use this get equation tuple helper function that we've given you. So this is going to sort of take your equation, look for these characters, and give you back a tuple of options. So this options tuple is going to contain your first number, and this one is going to contain your second number. So these are ampersand strings. You're going to want to parse these into integers. So I would look up the integer or float parsing function for that. And you're going to return a result unit variant. And notice here that we're using the unit type in our error variant because there's no sort of relevant information attached. Finally, there's the solve equation. So you're going to use your parse equation function within this and sort of solve using the result that you get back from parse equation. And then finally, we have a solve all function, which will return the sum of all sort of equations in a file. So we're going to give you a file path. You're going to want to open the file, read it out. I recommend you go back and watch lecture 2 for how to read a file. And you're going to compute the results of all equations in the file and add them together and return them in a result type. All right, that's all, folks. I know this was a little bit of a long one, but good luck in MP0, good luck in homework 1 and homework 2. Those have all been released, so you should be able to start them in Prairie Learn right now. All right, take care.